Okay, so we will now discuss about false position method. This is the second method, and this method is faster than bisection. We are uh, we will learn this method because false position method actually is faster than the bisection method. Okay, so we will approach to the solution in less iterations. Hopefully, we will expect that we will approach or we will get to the solution in less iterations. We have to iterate the loop less, so it would be faster. So, false position method, or it is also called Regula-Falsi. Okay? Regula-Falsi. This is an alternate name. So I'm going to consider this graph. I'm keeping this graph unchanged. Okay. So let's assume we have been given this same problem. We have to calculate this root, we have to determine this root, but the method that we are going to use now is the false position method. Okay, so the false position method actually uses the technique of determining a straight line in between these 2 points. So what we are going to do, we will consider a straight line through these 2 points. Okay, so this is one point and this is another. Our x high was given and x low was given, and we get these 2 points from the function, the graph of the function. Okay, now we are not going to calculate the midpoint by dividing it by 2. Rather, what we are going to do, we will consider a straight line that passes through it. Okay, so we will consider a straight line. Okay, so it would be the intersecting point with x, and we will consider it as our new x mid. Okay, so the way we are going to calculate the x mid is by considering a straight line. So let's assume this is our new x mid. We are not actually dividing it by 2. We are not bisecting the interval. Rather, we are considering this purple color straight line joining these 2 points. These 2 points, the given points, we are calculating the x mid. So if we go for the maths, then what would the expression for x mid? So we have 2 given points. The first given point is x low, comma f of x low. This is our one coordinate, this point, right? The coordinate for this point would be x low, comma f of x low. Or for simplicity, we can write it as y low if you wish. Okay, we can write it as y low as well. Okay, keep it f of x low, whatever. And the other coordinate was this point, right? So this point is x high, comma f of x high. So we have been given these two points, x high, comma f of x high. And if we have been given 2 points, we know how we can calculate the equation of the straight line, right? We know this. So what we can do, we can form a straight line, and then from that point we will calculate these x mid value. Okay, So the first thing we can do, we can calculate the slope of this straight line. This purple color straight line will have a slope, and we know the equation of the slope is this. Slope is m, and if we consider these 2 points, then the slope would be delta y by delta x. So this slope would be, let's assume f of x low minus f of x high divided by x low minus x high. Right? So this is our slope, and this is the first calculated slope, and let's assume we are going to consider, or we are going to calculate the slope using these 2 points again. Okay, we are going to calculate the slope using these 2 points again. So if we want to calculate the slope using these 2 points, or we can consider the straight line now. So if we consider the straight line, we will get this x midpoint as this, like this x mid will have these equation. If we consider this point and this point, the x mid will have this equation: f of x high minus f of x high times the inverse of this slope. Okay, so the value of the x mid will look something like this. This x mid will have the value, this x high minus f of x high times this x low. 1 over m is this portion, right? We are going to invert this. It would be our 1 over m. So x low minus x high divided by f of x low minus f of x high. Okay, so it would be our new x mid. It would be our new x midpoint. Okay, so that's the way how we are going to calculate the midpoint now in case of Regula-Falsi, because if we calculate the x mid using this formula, we can see we will reach to the solution in a much faster way. Let's do some iteration, then I guess it would be easier to understand. Let's consider this thing. If I zoom in once again, okay, so it would be our new x mid. I'm going to deal with these things. So it is the x mid value, and similarly we will calculate the function value for x mid. So if f of x mid, so this is our f of x mid. F of x mid is positive, and f of x high is positive as well. So we will forget this x high point. This we will forget this portion and consider it as our new point. So it would be our x high. It would be our x high, and this coordinate, and it would be our f of x high. And we are going to remove this straight line. And what we are going to do, we will consider one more straight line that will join these 2 points, this point and this point. we are not going to divide the interval by 2. Rather, we will consider joining the 2 points. Okay, so the straight line will look something like this now. So if I draw a straight line joining these 2 points, then you can see we are approaching the root in a pretty fast way, right? So I'm going to join these 2 points, drawing a straight line. Okay. Let's assume this is our straight line. So it would be our new x mid, then the intersecting point. So it would be our new x mid, and what we are going to do, we will check the function value once again. So this is the new function value, and we can see the x high, I mean the f of x high is positive, and this x mid, this is our x mid, f of x mid is also positive. So we will forget this x high point, and we are going to consider this point as our new point, and we are going to update this x mid as x high, right? So if we do one more step, so what we are going to do, we are going to draw one more straight line joining these 2 white points, right? These white point and these white point. We are going to join these 2 points using a straight line once again. So now if you can see, I guess, if we join these 2 points, we are pretty close to our root. This is actually a bit tough. If I join these 2 points, then you can see we are pretty close to our root, right? So after doing one more iteration, actually we will reach to our root, right? So if I zoom in a bit more, so we are pretty close to our root, right? So we are actually here, and if we do one more iteration, then we will get to this point, and if I join the straight line once again, we will actually reach to our root, right? So the method that we are using now, the false position method or the Regula-Falsi, is actually faster. Okay, this method is actually faster. We are approaching to the root in a faster way. That's the advantage of this Regula-Falsi method. So what's the difference between bisection and Regula-Falsi? The only difference is that we are updating the midpoint using a different formula. We are updating the midpoint using this formula. We are updating the midpoint by considering straight lines. That's the only difference. Okay. In case of bisection method, we were determining the midpoint using this formula. We were determining the midpoint using this formula. And in case of bisection method or Regula-Falsi, we are updating the midpoint, or we are calculating the midpoint using this formula. That's the only difference. The other thing is same as before. Okay. We will calculate the midpoint, then we will calculate the function value for x mid and check whether the f of x mid, the sign of f of x mid matches with f of x low or f of x high, and forget x low or x high, and then update it with x mid. The same iteration what we did in case of bisection method. Okay. After calculating this x mid, we will calculate f of x mid and do these checks and replace x low or x high with x mid value, and we will stop when the tolerance value is close to this. Okay, the approach is same as before. Okay, there is no difference in between the Regula-Falsi and bisection method. The only difference is the method of calculating the midpoint. Okay. So any queries about this portion? এটা কি বোঝা গেল নাকি বলেন তো, নাকি খুব একটা ভালো বোঝা গেল না? আচ্ছা, এই ইকুয়েশনটা কিভাবে আসছে এটা নিয়ে কি কনফিউজড হয়ে গেছেন নাকি না কিছুই বোঝা যাচ্ছে না? যদি কোথাও কোয়েরি থাকে তাহলে জিজ্ঞেস করতে পারেন। কিন্তু is the calculation clear to you how actually we calculated x mid here? Okay, I guess yes. So what we did, we actually calculated the slope first, the slope of this straight line. আমরা স্ট্রেট লাইনটার স্লোপ ক্যালকুলেট করেছি। তারপরে হচ্ছে আমরা এখানে আসলে কিছুই করি না, আমরা এই দুইটা পয়েন্ট নিয়ে আরেকবার স্লোপ ক্যালকুলেট করছি। যদি আমি সহজভাবে, let's do this calculation once again. What we did, we actually calculated the slope using these 2 points. So one point is x mid, one point is x mid comma 0, right? The y value is 0 here. The y value is 0 here. So one coordinate is x mid comma 0. If we consider this point, right? If you consider this point, the coordinate is x mid comma 0 because it is on the x-axis, and the other coordinate is this, the x high comma f of x high. So if we consider these 2 points and calculate the slope once again, so let's calculate the slope using these 2 points. Slope m would be what? The slope m would be a delta y by delta x. So f of x high minus 0, y1 minus y2 divided by x1 minus x2, right? So x high minus x mid. Then we actually equated these two slopes because this is actually a single straight line, right? So for a single straight line, the value of slope will remain constant. So the slope is this for this straight line and the slope is this for straight line. So we actually if I write it, we actually equated these two slopes to determine the x midpoint. Okay. So if I equate these two, let's equate these two by inverting each other. I'm going to copy this portion. So this is one calculated slope value and this was the other calculated slope value, right? So we actually equated them. Nothing much. So if we equate these two slope values, it would be, let's keep this thing in the left, it would be equal to this, right? So these two slope values would be equal, and from there we actually calculated x mid. Let's invert them, invert both of the sides. So we will get x high minus x mid divided by f of x high. It would be equal to, we are going to invert this portion as well. So here we will get x low minus x high divided by f of x low minus f of x high. And if I make this term to the other side, then we will have this thing x high minus x mid. It would be equal to f of x high times this x low minus x high divided by f of x low minus f of x high, and from there we are going to calculate the x mid portion. Okay, so if this x mid will look something like this, I'm going to take this term to the other side of the equation. So I'm going to take this here and take this term to the left, take this here. So x mid would be x high minus f of x high times this portion, x low minus x high divided by f of x low minus f of x high. Okay, so that was the equation that I written earlier without giving the details. Okay, so the difference of false position method with so this is our x mid. Okay, so this equation is our x mid. This method is x mid considering the Regula-Falsi method, the false position method. Okay, I wrote this expression actually earlier. Okay, so what's the difference in bisection and Regula-Falsi? The only difference is this thing, that in case of bisection, the x mid value was this. X mid value was x low plus x high divided by 2. So we are actually calculating midpoint by bisecting the interval. But in case of Regula-Falsi or the false position method, the x mid is having this formula, x high minus f of x high times this, x low minus x high divided by f of x low minus f of x high. Okay, that's the only difference. The rest of the steps are exactly same. Okay, so after calculating the x mid, we will do these checks once again, right? We will check whether x mid, we will calculate the function value, the f of x mid, and then so we will calculate f of x mid here, f of x mid, we will calculate the function value, and we will also calculate the function value here, f of x mid, and then we will check whether f of x mid, the sign of f of x mid matches with f of x low or f of x high, right? We will do these checks. We will continue to do these checks, and whenever we reach to a very close, a very small value, when this difference is less than our tolerance, we will stop our iteration and determine, or we can say our solution would be the determined x mid. ঠিক আছে, তার মানে আমি যেটা বলতে চাচ্ছি সহজভাবে, এই ফলস পজিশন মেথড আর বাইসেকশন মেথড এক্স্যাক্টলি সেম। তফাৎ কোথায়? তফাৎ হচ্ছে যে আমরা এক্স মিডটা কিভাবে ক্যালকুলেট করতেছি, এই মিড পয়েন্টটা কিভাবে ক্যালকুলেট করতেছি। আগের বার আমরা মিড পয়েন্টটা ক্যালকুলেট করতেছিলাম হচ্ছে এই ফর্মুলাটা দিয়ে। আমাদের যেটা বাইসেকশন মেথড ছিল, বাইসেকশন মেথডে আমরা এক্স মিডটা ক্যালকুলেট করতেছিলাম এবং ইকুয়ালি দুই ভাগে ভাগ করে, হ্যাঁ, ইকুয়ালি দুই ভাগে ভাগ করে আমরা মিড পয়েন্টটা ক্যালকুলেট করতেছিলাম। আর যে তারপরে ফাংশন ভ্যালু ক্যালকুলেট করতেছিলাম এই এক্স মিডে, যার সাথে মিলতেছিল ফাংশন ভ্যালুটা তাকে ভুলে যাচ্ছিলাম, ভুলে আপডেট করে দিচ্ছিলাম নতুন করে এক্স হাই বা এক্স লোকে। এই Regula-Falsiতে বা ফলস পজিশন মেথডে এক্স্যাক্টলি সেম কাজ করতেছি, তফাৎ হচ্ছে এক্স মিডটা আর এক্স্যাক্টলি একদম দুই ভাগ করে যেভাবে বাইসেকশনে করছিলাম ওভাবে করতেছি না। এক্স মিডটাকে আমরা এই ফর্মুলা দিয়ে ক্যালকুলেট করতেছি। এই ফর্মুলা দিয়ে ক্যালকুলেট করে পরের স্টেপগুলো একদম সেম, ঠিক আছে? পরের স্টেপগুলোতে আমরা আবার এক্সমিড এর ফাংশন ভ্যালু বের করব, তারপর চেক করব মিলে কার সাথে, এগুলো চেক করে ওইভাবে আস্তে আস্তে করে আপডেট করতে থাকবো, ঠিক আছে? অন্য স্টেপগুলো একদম এক্স্যাক্টলি সেমই আছে, অন্য স্টেপগুলোতে কোনো তফাৎ নেই, ঠিক আছে? তো এটাতে সুবিধা কি, যেটা যে বলছিলাম রেগুলার ফলস, এই ফলস পজিশন মেথডের সুবিধা কি? সুবিধা হচ্ছে এখানে আমরা দ্রুত সলিউশনে রিচ করতে পারবো। এটা তো আমরা দেখলাম, আমরা যেরকম স্ট্রেট লাইন কনসিডার করতে থাকি, স্ট্রেট লাইন কনসিডার করে করে এক্স মিড গুলো আমরা ক্যালকুলেট করি, তাহলে আমাদের এখানে ইটারেশন লাগবে কম, ঠিক আছে? এখানে আমরা সলিউশনে দ্রুত রিচ করতে পারবো। আগে আমরা বাইসেকশনে যত দ্রুত সলিউশনে রিচ করতে পারতাম, এখানে তার চাইতে আরো ফাস্টার অ্যাপ্রোচে আমরা সলভ করতে পারবো। ওকে, so the advantage of false position method is that we will reach to the solution, or we will approach to the solution in a much faster way. Okay? That's the advantage. But the steps are pretty much similar. The steps are pretty much similar. Okay. Okay, so these are the two methods that you will write in the code: the false position method and the bisection method. The third method, the Newton-Raphson, we will see this method and we will go for the code as well. For Newton-Raphson, we will show and explain the code, how Newton-Raphson method works. Okay, so I'm going to make a break once again.